Okay, let's get started with question 4 of exam 2. Two cars are moving from the same point. One travels south 60 miles an hour and one travels west at 25 miles an hour. At what rate is the distance between the cars increasing after 2 hours? Okay, so let's say we start here. One car is going south, and we'll call that y, and I know dy dt is 60. Now if I'm going west, and I'll call that x, that car is going at a speed of 25. At what rate is the distance between the cars, which is right here? At what rate is the distance between the cars, I'll call that z, increasing after 2 hours. So what I want is dz dt. Okay, so let's see what we have. Now, just to briefly mention, and you can check this in the textbook, the reason these are not negative is because it's a rate representing the distance of these two cars, and the distance that, well, like since they're starting here, the distance is increasing from the origin, and if it's increasing, its rate is positive. So just keep that in mind. I'm pretty sure that's how the book does it, so I want to keep it the way the book does it. Anyways, we want dz dt. So first thing we have to do is figure out a way to relate x, y, and z together. Now the way I drew it looks like a right triangle, which it is, and right triangles satisfy the Pythagorean theorem. So we have x squared plus y squared equals z squared. Let's see, what else? Alright, and then we need to find a way of getting all these dx, dy, dx, dt, dy dt, and dz dt. Well, if we differentiate this, that's exactly what we'll get. Now, since we're differentiating with respect to t, these are all going to be chain rules. So the derivative of x squared is 2x. But you got to then multiply by the derivative of x, which is dx dt. The derivative of y squared is 2y. Then you got to multiply by dy dt. And then this will be 2z dz dt. Now this is what I want, and I need to have values for everything else. So let's see here. We know dx dt. Oh, by the way, does everyone see that each term has a 2? So I can just get rid of those. Cross them off. Okay, so I need x and dx dt. Well, I know dx dt is 25. So what's x? Well, x is how far have I gone? In, what's the time? 2 hours. So how far have I gone in 2 hours? Well, if I'm going 25 miles an hour, then I've gone 50 miles in 2 hours. And going down, my car is going 60 miles an hour, so after 2 hours, it has gone 120 miles. So let's see, 50 plus y, which is 120, times 60, and they need a z. Well, this is z right here. So just use Pythagorean's theorem to find this length here, which I believe should be 130, but I'm checking on my calculator right now. Let's see. Yep, so 130. So equals 130. So that's going to be 130 times dz dt. I don't know what that is, but again, that's what I'm trying to find. So 50 times 25. So that's 1250. 120 times 60. 7,200. Alright, so then my left-hand side becomes 8450. Alright, divide that by 130, and we get 65. Okay, so dz dt is 65, so that means the rate at which these two cars are increasing is 65 miles an hour.